Hi everyone, in this video I will talk about iOS 14 widgets supported by the SAP Cloud Platform SDK for iOS in its latest version 6.0. iOS widgets are the more prominent topics discussed in WWDC 2020 by Apple because iOS 14 widgets differ from today widgets available in earlier versions. They're offering a redesigned appearance and expanded capabilities. So what does the SAP Cloud Platform SDK for iOS has in store for developers when it comes to iOS 14 widgets? With the latest version 6.0, the SDK supports powerful, configurable, and secure widget extensions out of the box. And what does this mean? I will explore by looking at a concrete example. I have an iOS project generated with the latest Assistant Mac app. And this iOS project is using two destinations. One, to consume the enterprise sales and procurement model, which is the sample service packed and available within mobile services. And the second destination points to the public Northwind OData test service. So the iOS project with the generated code then allows a user to select a destination for the widget, then allows that the user selects an entity set from that selected destination, and will render the top 4 entries for this entity set in a SwiftUI view, which then shows the technical key as well as the label for that technical key. In addition, the SDK provides various SwiftUI views used, for example, in the preview or in case the user has installed the app and added a widget but has not yet onboarded it. Also, the SDK provides deep linking capabilities, so if a user selects one of the rows here in the widget, then a navigation occurs into the app. The easiest way to generate an iOS 14 widget is to generate your project with the latest Assistant Mac app. The latest Assistant Mac app has a new checkbox widget extension. If this is selected, and this is per default, then clicking on Finish will create the iOS project with all the necessary code for the iOS 14 widget. It is possible to use widgets and related APIs from the SDK without using the assistant, but this is not part of this video. One quick comment about the statement regarding anonymous access. This is a new feature, also in 6.0, and this means that certain mobile service endpoints, like storage service, can be called simply with an API key and does not require that the user is authenticated. This is used by the default implementation of the widget to retrieve technical information from mobile service side initiated by the app extension. But this does not have any negative effect to the security configuration on a destination level. So let's talk about the 3 key components of a widget as it was outlined in the WWDC session. First, there is a configuration that identifies the widget and determines whether the widget is configurable and defines the SwiftUI views that show the widget's content. There is a timeline provider that drives the process of updating the widget's view over time. And there are SwiftUI views used by WidgetKit then to display the widget. By adding a custom SeriKit intent definition and an intents extension, you can let users customize the widgets to show the information that's most relevant to them. And for all of these areas, the assistant is generating code artifacts, and we will have a look at these in a short moment. But beyond the WidgetKit generated code artifacts. What does the SDK provide? It provides for two concepts which are non-trivial a solution. First, how to share data securely between an extension and an app. And second, how to keep data up to date with background tests. So to support all these, the SDK changed the structure of the generated project significantly with Assistant version 6.0. So far you were used that an Xcode project then which was generated contains a single target, and all source code and resources were accessible to that single target, including the generated OData proxy classes. It should come of no surprise that now an app extension to handling the widget was added as a second target, but also a third target is now getting added to the iOS project, the intents extension to make the widget configurable. To have then code modularity and allow that source code and resources can be accessed by different targets, all these source files and resources were bundled together into a shared framework. And last but not least, OData proxy classes were bundled into destination frameworks. So in our example, we have two destinations pointing each to an OData service, which will result into two destination frameworks containing then the generated OData proxy classes for entities available for this destination. Next, I would like to explain the widget reload events and how these are used or handled by the SDK. Widget use Swift UI views to display their content, and WidgetKit renders the views on your behalf in a separate process. As a result, a widget extension is not continually active, even if the widget is on screen. WidgetKit gets a timeline from your provider and uses it to track when to update your widget. But also an app can tell WidgetKit to request a new timeline when something affects a widget current timeline. These are so-called app-driven reload events. And from the SDK, we believe that it's crucial that a widget shows data immediately. So during the initial onboarding, the SDK provides a pluggable option to prefetch widget-related data. The assistant generates a new onboarding step called auxiliary communication step. Also, the generated view controllers were adjusted to request that the widget gets reloaded when a user creates new data or a user updates existing data. As I said, these are app-driven reloads and allows the widget to reflect relevant changes based on the state of the app. Then there are system-driven reloads. A timeline entry has a reload policy which allows WidgetKit to determine when to request a new timeline. And also, popular and regular visited widgets get more processing time, which will lead to more timeline requests. Next, I would like to explain how data sharing works from a high-level perspective. I won't go into details because this would then extend the time frame for this video. For now, please be ensured that data shared between the app and its extension is encrypted, and the SDK introduced a multi-layer encryption design to protect credentials in the app so that data loading operation can be performed without asking the user for his or her passcode. Remember, prefetched data are encrypted in a shared data store, accessible by the widget extension as well as the containing app. Per default, this is the keychain and uses an access group for keychain sharing. When WidgetKit requests a new timeline, then the generated timeline provider will return the cache data from the shared store immediately, which leads to a snappy user experience. The generated widget intent timeline provider retrieves the user configured information for the particular widget via its intent, the first argument shown in here. Besides returning the cache data, an auxiliary data request gets serialized and stored in the keychain until the containing app can pick up and serve this request. The data request can be processed at some time because the containing app scheduled a background task to process a newly introduced flow in the SAP Fiori Flows framework, adequately called background. When the operating system provides computing resources, then the onboarding steps registers to this background flow will be processed. The new generated auxiliary communication step, which is registered has registered steps for the background flow, will invoke the data loading by asking all types which conform to the new and generated widget data loading protocol. As this is a generated code artifact, you as an app developer has full control over it and you can change it to your needs. The cache data will be updated in the shared store and the containing app will request WidgetKit to reload the widget. Then WidgetKit then takes the updated information and re-renders its views. The SAP Foundation Framework provides two classes to handle the security aspects of each respective process. These are fundamental, and their usage is orchestrated by the generated app. Still, I mentioned these classes in case you're interested to use widgets without the assistant-generated code. The Auxiliary Security Manager is handling the app extension, and the Security Manager is for the containing app. Now I would like to jump into the generated code base to get you familiar with the new project structure and generated artifacts related to widgets. And I will tweak the default implementation of the widget to do so. My goal is first to tweak the preview. This means when the user attempts to add a widget to his or her device, the user will first see a preview. And I will change the title and the description, and I will change the static preview data, and also I will add some nice chart diagram. My second goal is then in particular to the customer entity set displayed for the enterprise sales procurement model. Instead of showing a technical ID and its label, I want to show the first name and last name, as well as the email address. I want to load the top 4 entries of customers coming from the US only, and I want to show them this country code as well in the Swift UI. So let's get into it, and we will do so by having a look at the generated project. So as explained, it's no surprise that the main target has now 2 new capabilities: background fetch and background processing, and keychain group, which is then for keychain sharing, which is the same for the new app extension for widgets. Also, there's a third target added for the intents extension. Code which is needed by the main target as well as the app extension is bundled in the shared framework, and this app is using 2 destinations, so therefore there are 2 destination frameworks. And good to know for our example is that the customer entity set and entity type of the ESPM model has a property country, which we will then use for our example. Now, what's the main entry point of our widget? So this is the widget.swift file, and the struct conforms to the widget protocol defined in the WidgetKit framework provided by Apple. We also see here that the main annotation here is an indicator that this is the main entry point. And in the computed body, we see the widget configuration, that this is an intent configuration. We see the timeline provider, and in the content closure, we see which SwiftUI view should be used by WidgetKit to display the widget. And we will have a look into this. So this is then a delegation to the widget entry view. And in here, depending on the state of the app, different SwiftUI views are shown. If the app was installed and the widget was added, but the user never used the app before, data cannot be shown. So in this case, then this information is then shown to the user. But in most cases, the user has onboarded once. So then in here, we will see that there is a header view, which represents this part here, and then a list view. And the list view iterates over its model, and for each entry, a widget row view gets created. And if we have a look at this, then we see that this is a vertical stack with two texts, one showing a value and then showing a key. And looking at the model, it is a protocol which has three attributes, one for value, one for key, and an optional image. So let's start now by tweaking the title and the description for the preview. We're going back to our start point, and we see here the configuration display name and the description are outsourced into source code-based configuration file. So we will go into here, and we can then easily tweak this and adjust also the description used in the preview. Next step, I want to change the data used in the preview. So for this, we will have a look at the widget, at the generated widget intent timeline provider, and here we see which static data are used for the preview, and we are replacing this with a different implementation. Okay, done. And the adding the chart I will handle later, but I also want to change here this placeholder here, so we will say then this will be customers as a string. Okay, so the next step is that for customers, we only want to load the top 4 entries for US customers. So, and for this, we will have a look at the widget folder in here, and we see that the auxiliary communication step would prefetch data for widget during onboarding and processes then and refetches data when the app is in background. And in here we see that so-called widget data loaders are getting called. And this is this generated protocol which you can tweak and change because this is part of the generated code, but I will leave it as it is, and I will have a look at the implementation of this protocol. So the assistant is generating for each destination an implementation via extension, and for customers we see here that the data query is used to select the top 4 entries, and we can influence this now simply by adding a where condition. And we only want where the country equals to the US. So this should then so in this case we have now adjusted that the top 4 entries will only be for customers from the US. So as a next step, I would like to change the actual UI. And let's go back in here to the Swift UI row view, and we see here that the widget row view model has here value and key, and I don't want to change the model too much, so I will keep the existing properties in this protocol, but I will add some new one, and I will add a country code, an optional string, and chart data later on for the chart, and I will provide a default implementation for that. So per default the country code will be nil, and the chart data will just return some random information. But now let's have a look at the implementation of this protocol. This is also realized via extensions, and for the customer we want to change the implementation that actually the value is representing the first name and last name. The key is then the email address, and we return as the country code the country. And we then have to change the actual UI. In this case, we replace the main content view by saying that the second row is actually an horizontal stack showing first the key, which is then now the email. And if a country code is present, we are using a spacer to push then the text for the country code to the right hand side. And for our first target, to say for non-customers or for situations where no country code is provided, we want to show some charts, then we are providing here an else block to use then a chart view, which is a Swift UI view. And what I have not told you is that I have tweaked a little bit the generated project a tiny little bit. What I did is I have added here a Swift package from the open source project provided by the SDK, and it contains Swift UI views for charting, and we are importing now this framework, and therefore we can use this code. So, and this is all what we need to tweak the default implementation for the preview, to have it in such a way, and that for customers that we have a nice and more concise view of data. So, and that's it for widgets. Thank you very much.